All right, ladies and gentlemen, for our final act of the evening, we have Gabriel Mott. Gabriel Mott is obsessed with how and what our eyes see. He's currently constructing a traveling immersive color box as part of his effort to evangelize color relationships. He owns and operates colorisrelative.com, a website dedicated to educating and inspiring people about color.
Thank you, Ian, and thank you, Maggie. Thank you both so much for putting these on. I am super, super excited to be here. Thank you all for coming. I'm glad everybody's here. My first slide, if you can see this, is a chain link fence, a living room, and a bowl of paper towel rolls. When I was a kid, I would sit in the living room and I would watch little pink and green dots hover around in the air and float, and I found out I could control the movement of them with my eyes. And if I jerked my eyes around, they would jump around. Anybody else do that? And then I would go outside and look at a chain link fence, and what I learned later was I would make my eyes go stereo, and the focus would make it just really cool looking. When you were a kid, you're probably told you could take a paper towel roll and hold it next to your hand, like this, and look with both eyes, and you put a hole right through your hand. Who did that? So, Van Gogh said, "I am completely absorbed in the laws of color if only they had taught us them in our youth." If they had taught me the laws of color in my youth, I would know what I was doing when I was playing with my eyes. The art that was coming out with the Impressionists was based on laws of color that were being researched and discovered. And this is a piece done in 1890, 120 years ago, called Irises. And by the end of this presentation, I'm going to talk about one law of color that makes this a vibrant painting. So before we get into that law, I'll discuss some other laws. The first is complementary colors and after image. So take a moment here, stare at this image for about 10 seconds. Just stare, fix your eyes, relax them in the middle of the screen, in the middle of the white. I'll move out of the way here for a second. You're looking at magenta, cyan, and yellow. Relaxing your eyes, keep relaxing your eyes, and keep staring at the white. And you'll see an after image. What happened is the cyan, magenta, and yellow burnt the back of your eyes in a sense, so now you see the complements. You see red, green, and blue in those places. That's another topic for a different presentation, but those are the primaries of light, and cyan, magenta, and yellow are the primaries of paint, ink. So that was the first law. The second one is value and illumination. Value illumination means when our eyes see black and white, essentially. Now this is really cool because black and white illumination is processed in a different part of our brain than color. And a lot of living beings on this planet that have eyes only see black and white, or only luminance. Another topic, but that's the second law. The third law is simultaneous contrast. So how many colors do you see here? 3, 4. Okay, watch this closely. There's a moment where they're next to each other, they seem different, and our eyes do this sort of jump. They sort of click into seeing it's the same color. So the context changes everything. Color is relative. To me, it feels like magic. Now, halation is the fourth law. I'm claiming in my presentation tonight, it's called Halation is better than magic, that what's so cool about this is it's better than a joke, it's better than magic, because you can explain halation and it still works. If you explain magic, a magic trick, it's no longer, doesn't work anymore, or a joke doesn't work anymore once it's explained. But halation, you can explain it, which I'm going to do, and it will still work, and I hope, in fact, will give you more access to seeing art better, and if you're an artist, creating more vibrant pieces. It's also, I think, important in this day and age to constantly challenge our assumptions. And so halation helps us do that, and I'll show you how. And I was just reading in the New York Times an article about growing older and how our brains can still learn, but one of the things about the brain as it gets older is it's really important to present ourselves with disorienting dilemmas. This is the #2 sent article in the last 30 days in the New York Times. So constantly finding disorienting dilemmas to present yourself with is a way to keep yourself smart as you get older and older. So halation is going to be a key to that too. So we can all agree this is a background is gradient from dark to light, and you're looking at a sphere where it's light on the top and dark on the bottom, right? Now watch closely how the sphere changes when we remove the context. I'm going to let this one play for my allotted 20 seconds, because watch carefully. The sphere itself is not changing. The sphere itself is not a sphere, it's a flat gray circle. And because of the background changing, it appears to be a sphere. There's a reason our eyes do this, and it's actually a really brilliant evolutionary reason. The first question when I showed this to a group was, does it work with color? So I tried it. So now in color, it still works. That's a flat blue circle, but it appears to be a sphere, but it's a value change that's making that happen. So let's try it with no value change, no change in the luminance, just with color. You're going to see a little bit of orange at the bottom of the sphere and a little bit of yellow at the top of the sphere. And the sphere itself is a single orange color. The context is changing actually what we're seeing as the color. So what is going on here? When I was a kid, I was mentioning the weird things I did, looking at those little dots float around and looking at, stereovision chain link fences. I also get this double effect. So looking at an orange like this, if we were focused at the tree back there, we wouldn't see one orange, we'd see two oranges, right? Because our focus is at the tree. So just do this with me. Hold up your hand for a second, look at me, and you're going to see how many hands? Two hands. One of them you can see through, right? But it doesn't look like this. Look at the slide. Look carefully. Look back at your hands. What it actually looks like, watch very carefully, is this. The difference is that it's pretty much transparent through all of it, but the edge is where you see the color. So back to your hand, you see right through that hand. There's nothing there. You're seeing me, or you're seeing the wall or the screen through the hand. The edge is what your eye picks up. So here's a single swatch of green color. Now, if we add its family members, the parents, these are the two colors that are used to mix to create that middle green. Watch what happens to the middle green. If you look carefully, it no longer looks like a single swatch of color. It is now aware of its surroundings. It's picking up a little bit of the dark green from the right on the left part of the middle swatch, and a little bit of light green from the left on the right part of the middle swatch. It appears to be a gradient, just like that circle did. It's picking up the colors around it. This also passes the pencil test. So if we block out the middle lines there, watch what happens in this last one. It'll seem like the last two colors are the same color right there. This is something invented by Dick Nelson, who's a color teacher up in Kula, who studied with Joseph Albers. And he would make these matrices where each corner is the parent, and you're making whole families. Every single square in this picture is a single swatch of color, but they appear to pick up other parts around them, and they become blends, which makes it very useful for creating transparencies, or appearing as if it's transparent, and also just creating a vibrancy. The eyes love this stuff. The eyes eat it up. It looks like it kind of glows. So what's happening here? Halation is caused by an evolutionary trait where our eyes are being very efficient. It's almost like a JPEG if you like computers. But the eyes look at a whole wall of color, like the wall up there, and it's sort of a peachy color, and they basically estimate, got it, all peach. Where's the edge? The eyes look for the edge. They define the edge, and they let the rest of it kind of be an estimate. And so those colors around, it's going to create a blend and a gradient. And it also, so that we can see better, will emphasize the contrast of the edge. I hope that you'll be able to look at art now, or maybe create art. In this case, you'll see Van Gogh was using halations, where he's taking distinct blocks of color from the same parents and putting them next to each other, and our eyes, without us even knowing it, are picking up things that look vivid, bright, brilliant, fun. Our eyes love it. As an artist, I've used these techniques to create artwork that is transparent, translucent, and plays off of each other. And I hope that you can now look at art that you'll see and appreciate more what's happening and why your eyes love the halations. Thanks very much.